follow along. And it's easy because it's just right here. Oops, I need my graph. Okay, so in what we're going to do is we're going to talk about assignment number 2. Assignment number 2. And I'm just going to focus in on the application part. Okay, those are the only ones that I'm going to try to do. Because the other ones are very straightforward, right? I hope they are straightforward. So let's take a look at question number 3. A hot air balloon is flying at an altitude of 1,236. Now, let's pause it for a second and say, oh, well, is this kind of relevant to us? Like, do we understand this? So, probably have heard of a hot air balloon. Yes. These are like the Remax flying around. So it's flying at an altitude of 1,236. So what does that mean, altitude? What is an altitude? A height. Yeah, height. So that's how far up it is from the ground. That's what altitude is. It begins descending at a rate of 10 meters per minute. So what does that mean? It begins to descending. What does descend mean? Descend means to go down. Okay, so now we have a feel of this story or context. This is a context because it's just has a meaning. So it's right now it started off at 1236 meters and it starts to descend at a rate. Okay, can you see here the word rate? 10 meters per 10 meters per minute. That's actually the slope of the line, right? Because when we talk about the slope, that's the rate of change. How is the y changing as x changes? The balloon's height from the moment it begins its descent until it reaches the ground is given by the function. Okay, so now here's a function. The function are the things that relates height and time, right? Those are the two variables in here. We have a height, how high it is at a given time. So let's start putting that in onto our calculator. Now, we can't put h and t on our calculator, right? We can't put h and t on our calculator. So when we put this onto our calculator, it's going to be on y1 equals to negative 10x plus 1,236. Okay, so let's do that. So I think everyone is comfortable with that piece. Okay, I gotta, because haven't used this today at all, so I'm just gonna clear off everything. Okay. Now before we press graph, what kind of graph are you thinking about? How does this graph go?
Decreasing
To the
left.
decreasing to the
Oh,
decreasing to the right. It's going down, right? It's going down, decreasing. Okay. So it's decreasing, and what makes you think it's decreasing? It's going down.
The slope is negative.
Because the coefficient, the leading coefficient is negative. Okay. What does this number mean? The y. Y. Mm-hmm.
I just had a question about the coefficient.
Oh, okay.
So if it was backwards, the coefficient would still be 10x.
It would still be negative 10x, yeah.
The coefficient is always a number with a variable.
Correct.
Okay.
Yeah. So So this number here, 1,236, that's the y-intercept, right? We said last time that in the equation, mx plus b, this is the slope of the line. That tells us the direction if it's increasing or decreasing. And then this number tells us the y-intercept, where it crosses the y-axis. So, and then they gave us a context here where t represents the time, okay, we know that, measured in minutes, and then the h is the height, in meters. So graph or sketch the graph of this function. Okay, so we kind of know what that kind of looks like. We know it's a line going down. So let's press graph. And I'm going this along with you so that we can say, oh, if this happens to me, what can I do? Okay? Okay. Now, I'm pretty sure because we resetted our calculator, we've entered our equation, and then we press graph, and I'm pretty sure everybody has this graph.
Yeah.
Now, what does that tell you? Okay, what's wrong with this graph? Well,
The window is not.
okay, yeah. So the window, okay, there's nothing wrong with the graph, it's just that we cannot see the graph. And that, you are right, we have to change the window. So how can we change the window? How can we change the window? Well, the next question is, I know I'm gonna change a window, but how do I change a window? Okay, how do I change a window?
We can see the number.
Okay, so we know that,
We have
okay, what do we know? Let's take a look.
Minimum.
We know that this is the y-intercept, and we know it's gonna go down. So it's gonna go like that. Now, our time, can the time be positive? Yes. Can the time be 0? Yeah, that's okay. Can the time be negative? Can
No.
the time be negative? In this context, no, right? No, we can't go a negative time. So our time cannot be negative value. Can the height be positive?
Yes.
Yeah, because it's above the ground. Okay. Can the height be 0?
Yes.
Can the height be 0?
When it arrives, yeah.
When it's on the ground.
Yeah.
Can the height be negative?
No.
No, because that means it's going to be below the ground. So in that particular case, I'm going to sketch it here for a second, okay? Because we try to make sense of our graph.
Yeah.
So this is the time, and then this is the height. The time could be positive, but it can't be negative. So it can't be negative, so we don't need to do this part, okay? What about the height? The height could be positive,
Yeah.
but it cannot be negative, so we don't even need this part here. So which quadrants do we need?
Quadrant 1.
Just quadrant 1, right? So just quadrant 1. So we just need quadrant 1. So in this case, if it's in quadrant 1, so this, we can see that, oh, okay, that's our y-intercept, and it's gonna go down. It's gonna go down. Okay? So how do we go from there? Well, what do you think is the height up here?
1250.
10? Okay, let's see.
500.
Okay. Let's see here. Let's go here. can you press second function, graph. Okay, second function graph. That gives us our table of values. What does that mean? So the x is the time
Okay.
in minutes, and the y is height. So what does that mean?
From 0
Zero, zero what?
1,266.
0 minutes.
0 minutes. 1,000.
Height is
12,36.
1236 meters. Okay. In 1 minute, after 1 minute, the height of the balloon is
12,26.
1226. 2 minutes,
12,16.
1216. So as you can see, it keeps going down, right? Okay. So if you take a look at that, okay, I'm going back and forth in here. Time, height. So 0 minutes is 1236. So that actually is our starting point. Okay, 1236. So it would be over here, 1236. Now, that's where the y-intercept is. It's going to keep going down, 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 down. Okay. So we can see, okay, well, if this is the time, what do you think the time is? What is this? What do you call this particular point? This is called the x-intercept. X-intercept. At x-intercept, y is 0. Okay. Well, if we keep going down, we know it's going to keep going down. That's going to take a long time. What do you think?
500.
Okay. How many minutes? Right now, I'm here at 40 minutes. The height is 836. Okay. I'm at 50 minutes. The height is 736. So what kind of x? Our x minimum is going to be 0. What would be the x maximum?
500.
1250.
1250?
500.
500? Okay, well, let's give it a try. Let's give it a try. Okay, so let's go window,
1250.
0, 0, and then maximum is, did you say how many? 500? Okay, let's go. We can adjust it. We could always go back and adjust this later. Okay, now with the y's. Okay, what's the y values that I'm gonna do?
0.
Okay, what's our lowest y value?
0.
Y minimum is 0. What is the y max? We can go 1250, yeah. We're gonna go a little bit higher than the y-intercept, and that's okay. Let's not do the scale for now. Okay, yeah, we'll just see how it goes for now. That would be 0. Y max is 1250. Okay. So this is the graph that I got from 0 to 500. Do I need to go up to 500? Okay. You could probably go, so it's from here to here is 500. How many minutes do you think this is? 50? Okay, if we go 50, that's not going to be enough. Okay. Okay, let's go 300. So x max to 300. Okay, so that's 300. So that's from 0 to 300. Do we need to go up to 300? Probably not, right? Okay, but that's okay as long as we can see the graph. We're supposed to sketch. I'm gonna do the sketching here. So we know that this is gonna be time over here in minutes. And then this is the height. We know that we're gonna go up to 1236 as our y-intercept. So what do you think is a good or appropriate y values or scale that we can use? So we need to go up to 1236.
What about 200?
We can go by 200. Yeah, do you think that's gonna be enough? 200, 2, 4, 6, 8, 10. So if we go by 200, it's gonna be 200, 400, 600, 800, 1,000, 1,200, 1,400. Okay. Yeah. So we could approximate where 1236 is. So 12. This is going to be 1,300. So 1236 would be probably somewhere around there. Okay. So 1236 is around there. But we still don't know where it's going to land in here. So we did that algebraically. We also did that using the graphing calculator. What I'm going to do because of the time constraints, we're just going to do that on a graphing calculator, okay? So how can we figure out the x-intercept using our graphing calculator?
Second function trace.
Okay. So how can we figure out the x-intercept? So if you wrote it down here, this is like nice, easy steps. We said to calculate the x-intercept, first, we're going to enter y2 equals 0. We're going to y2 equals 0. And then we're going to go second function trace. Second function trace. Second function trace. And then we're going to press 5 for intersect. We're going to press 5 for intersect. And now it's going to ask us a whole bunch of questions, which the answer are yes. So enter, enter, enter. So okay. So what does that say? Our intersection is at 123.6. X is 123.6. Y is 0. So that tells us that the x-intercept is 123.6. So 123.6 for that point. Y equals to 0. So that means 123.6 minutes. The height is 0. 0 meters.
I got different answer.
Mm-hmm.
I got different answer. Why?
You got a different answer?
Yeah.
Oh, interesting. What answer did you get?
X is 150 and Y is minus 260. I'm practicing.
Oh no, it's still going. Enter, enter, enter.
Doesn't go.
Oh, it doesn't go.
I want to practice
Oh.
to work at home.
Oh, because you forgot the y2 equals 0. That's why. Okay.
Sorry, it's
Okay, is that good?
yeah.
So that tells us 123.6. So how do we label this or graph this on our graph? What do you think we should go up by? What do you think the scale should be? We can go by 10. So do we have time? So 10, 20, 30, 40, 50,
20.
60, 70, 80, 90, 100, 110, 120, 130. Okay, yeah, 10 minutes sounds good. So this is 10, 20, 30, 40, 50, 60. So that is 123.6. So that 120, 125, so it would be right there. So we have our points in here. Those are our points. So the y-intercept is 0 minutes, comma, 1,236 meters. That's the y-intercept. And then over here, this is our x-intercept at 123.6 minutes, 0 meters. Is everybody okay with this part?
Now it's clear.
So we're actually not completely relying on our graphing calculator. We actually need to think about this before we even graph it. Okay, so we look at different clues on how this graph is going to be. So that's the graph. Now, let's take a look. Next one. I'll put this back in a few minutes. Let's take a look at letter B. What does the T represent in this situation? What does the T represent? So the T represents the time. Time in minutes, right? So the T represents the time. What does the H represent?
Meters.
The height in the middle.
The height. So height in meters. Okay. Now this one's a little bit different because what does the H-intercept mean? Not the H, but the H-intercept. Okay. Oh. Okay, so the H-intercept, this is the H axis. The height-intercept would be how high it is at 0 minutes, right? So the H-intercept means the height at 0 minutes. Okay, what is the height at 0 minutes? Is that okay? I'm gonna.
If you ask us what is H-intercept? Can he ask us what is h-intercept?
Hmm?
Can it ask us h-intercept?
Yeah, we can. Yeah, the question could be what is the
H-intercept.
h-intercept?
So what is the answer?
If the question is what is the h-intercept, it's 1,236. But then this one here, they ask us what does the h-intercept represent? That's the height at 0 minutes. So that's the initial height. Initial height. I'll let you write it down. The next question says, what does the t-intercept represent? Okay, they didn't ask us what is the t-intercept. They asked us what does it represent? Okay, what does it represent?
The time it represents in 0 height.
The time, so this is the age, that the t-intercept, this is the time it took to reach 0 meters. So the time it took to reach 0 meters. Or another way, yeah.
You also just put time at 0 meters.
The time, say that again.
Time at 0 meters.
The time at 0 yeah, you could say that. Or you can say the time it took the balloon to reach the ground. Right. So that's another possibility too. The time the balloon took to reach the ground, because when it's on the ground it's 0 meters, right? Yeah. Okay. So the t-intercept represents the time that the balloon took to reach the 0 meters, which is the ground. Okay. Let's take a look at letter F. Is that okay? Are these okay? B, C, D, and E? Yeah, okay. Letter F. How long does it take for the balloon to reach the ground? How long does it take the balloon to reach the ground?
160 hours.
How many? Okay, how many minutes did it reach the ground? 123.6 minutes. 123.6 minutes. Okay. So far so good? Is that okay? Okay, letter G. Does the graph continue in both directions? We kind of answered this already.
Yes.
Does it continue in both directions? So does it mean, can we graph it like this? It continues
I
to
don't
the
think so. No, it's done.
and to the right?
Using quadrant
It's done.
Yeah, okay, why is that? Why is it that it does not continue in both directions?
The minute is finished and the ball is already landed in the ground.
Okay, maybe one person at a time. Okay, go ahead.
Because it's already landed in the ground
Mm-hmm.
and the time is arrived at 0. So the time can't go minus.
The time can't go negative,
Negative.
minus. Okay, yeah, okay, good. Anything
The
else?
graph is decreasing, it's not increasing.
Okay,
because we're only using quadrant 1.
okay. So let's put all three answers together. So the time can't be negative. It's decreasing.
We're only using quadrant.
We're using only quadrant 1. Okay, so put it all together. Okay, so the time and height cannot
Go.
be negative values, and we only need, okay, we'll put that in quadrant 1, right? Because if the x value or the time value can't be negative, so that crosses off quadrants
3, 2, 3.
2 and 3, okay, when the y value, which is the height value, can't go negative, so that crosses off which quadrant 3 and 4. So we're only really left with quadrant 1, okay? Because this is a context, there's meaning to the situation. We can't go negative time and we can't go negative height. Negative height will bring us down below the ground, and we don't want that. Are there any question about that one? Is that okay? Is that good? Okay, I'll give you a moment to write that down.
How about the H?
Yeah, we will talk about that H. What is the appropriate range for this problem? Okay, range. Okay, let's think about range. How did we define range again? Range are the possible y values. Okay, so range are the possible y values. Well, the y values are the height values. So range is the possible y values or the height values. So what are the possible height values in this situation? What is the possible height values in this situation? So you look at this one here. This is the possible height values. This is where your graph is. Okay, this is where your graph is. And what's your possible height? Your lowest height could be, your lowest height is 0. What's your highest height? 1236. So okay, what are the possible heights? It could be from 0 to 1236 and anything in between. So we can't go in this situation anything above 1236, and we can't go below 0 meters. So the possible range are from 0 meters to 1236 meters. So from 0 meters to 1,236 meters and everything in between, right? From 0 to 1236. How's that one? Is that okay? All the values in between. How do you feel about that one, number 3? That okay? So there's a context there, there's meaning. It's not just some random equation. I actually, let's go to number 4, and I'm gonna try to do the drawing of the graph last, okay? I'll draw the graph last, or not last, but I won't start with that one. Let's read this one. So Emil currently has $200, okay, $200, and spends $20 each week. The function A equals to 200 minus 20W describes his spending pattern. Okay. Now, what's happening as weeks go on? What's happening to the amount?
Minus decreasing.
Decreasing, because remember he started off with 200 and he's spending $20 each week. That makes sense, right? Because if that's me, I'm spending $20 each week, then my amount would go down week after week after week. So let's go ahead and let's clear everything off. Okay, let's clear everything off. I'm gonna go second function plus 712. Okay, clears everything off. And then we're gonna type this in onto our calculator. Okay, so let's type that in onto our calculator. Okay, and then the W, I'm gonna type in X. Because we can't type in A and W. Okay, now let's first take a look at the table. Okay, that kind of gives us a situation, what's happening in here. So second function table, or second function graph. Okay. What's the meaning of 0 to 100 to you? What does that mean?
Before we starting.
Okay,
Spending.
at 0
$200.
weeks, at 0 weeks, he has $200. Yes? What about 180?
Decreasing by
1 week.
What does 180 mean?
At the first week,
Out of-
$180.
After 1 week, it's $180. Okay. How many weeks do you think it will take for him to have no money? 10 weeks? He won't have any money? Okay, let's go 10 weeks. At 10 weeks, he has $0. $0. Okay, so as you can see, that pattern is going down. It keeps going down. There's a meaning to that, right? So let's start with the B. What does the variable W represents in this situation? Weeks, number of weeks, right? Number of weeks. Okay, we'll start off with that. Letter C. What does the variable A represent in this situation? What does the A represent in this situation?
Amount?
Amount, yeah. Is A is the amount of money Emil has. Okay, so A represents the amount of money that he has. Okay, now here we go. What does the A intercept mean? A intercept mean, it means the W is 0. A intercept, that's when the amount of money he has at 0 weeks. Okay, another way of writing that is the initial amount that he has, right? He started off. Okay. What does the W intercept mean? W intercept. W intercept, so that means the amount is 0, right? So W intercept is the number of weeks when he has $0 left. So W intercept is the amount of weeks or number of weeks that he has $0. Okay. Now that we have some of those values, okay, let's graph it. Okay, so let's graph. Okay, let's graph that one. Oh, that's such a weird graph. Right? That's a weird graph right there. How can we change this graph? So, let's take a look. We know that this is time and amount. Okay. I'm gonna start with this one here. Can we have negative weeks? Can we have negative time? No, so we cross this off. So since we're crossing this part off, that means we don't need quadrant 2 and we don't need quadrant 1. Yeah? Is everybody okay? So we can't have negative time. So we're crossing that negative time. When we cross that off, then we've disregarded quadrants 2 and 3. What else can we disregard? Okay. We are having an assumption that he can't have negative amount, right? He can't have negative amount. You know, once he spend the money, it's gone. It's gone. So no, nothing in here. So we're also disregarding quadrant 4. So what's left over? We just need quadrant 1. Okay. So we know it's gonna go down. We know it's gonna go down because the slope is negative. Slope is negative. So what is the y-intercept? Y-intercept is what? 200. So 200. So the y-intercept is 0 weeks, $200. And what about the x-intercept or the time-intercept? I think we kind of figured that out already. This one is 10 weeks, 10 weeks, $0. So at the x-intercept, the y is 0. Let's graph that one. I'm going to graph it. So this is only in quadrant 1. So we need to go up to 10. What do you think the scale should be? What that? What should we go up by? Weeks would be 1, 2. Yeah, that's our 10 weeks. And we need to go up to 200 in here. So what do you think the scale should be? 20? Okay, so we can go by 20. So 20. So this is the amount in dollars. And then along the x is the time in weeks. So we started off with 200. Now his spending habits is $20 every week. So $20 every week. So at week 1, it would be 180. Week 2 is 160. Okay. So that's our graph. It's a representation of weeks. We can draw a graph here. Draw your line. Okay. I want to make mention here that remember we don't go to the left anymore, right? Because we can't go negative time. And then we're going to stop here at 10. We're not going to go past 10 because we can't go with a negative amount. So here's our graph. So the graph is there. Let's just take a look at letter F. Determine the value when A equals 0. Explain the meaning of this value of W. Determine the value of W. Okay. So can we figure out the W when A is equals to 0? So when A is 0, what is the W? 10 weeks. Okay, 10 weeks. And what does that mean? What's the meaning of this value? This means it takes 10 weeks when his amount is $0. So i.e. when he runs out of money. Okay. Is that okay? So we took, I'm not gonna leave it. Now we took our time going through question 3 and question 4. We didn't get a chance to go over question 5 and 6, but give those questions a try. Tomorrow, we will continue on with these. Tomorrow we will continue on with these. And then if we have time tomorrow, then we'll get the lesson 3 started. I'm really pressed for time. And
Is that